Well, it's I didn't know exactly what Tom was talking about, but indeed there is some continuation and a good link, I think. So good evening or boa noite to the Portuguese people. And before I go actually into my talk and talk about socio-technical architecture and how excited I'm about it, just briefly introducing myself. I'm currently a principal tech lead at bol.com, which is the biggest online retailer in the Netherlands and Belgium. And and for the last 15 years or so, I've been doing a lot of different things, among which been academic, did a PhD in computer science. I've also had my own startup company for a while, but for the last 6-7 years, I've been working as a software engineer and software architect in quite a few different companies. And when I'm not on my full-time job, I like to write and research on these topics that I'm going to be talking about today, and you can find more about that on my website. You also have here some information about how to reach me. You can also DM me on Twitter if you want to reach out. And some fun facts. So I come from from Portugal. Unfortunately, not today. We cannot be there physically in Lisbon, beautiful Lisbon. But I come from the north, in the north interiors. You can see there the smiley face, about 90 kilometers from Porto and like 400 from Lisbon. And I lived there for 25 years of my life. I'm not 25 anymore, as you may notice. And for the last 15 years or so, I've been living abroad. Lived in Sweden, in Switzerland, but short stays. And now for the last 13 years, I actually have been living in the Netherlands. And you can see here some art behind me. So this is from my kids, which I hope they are now sleeping and they don't come in to the room. And now let's dig into the topic of my presentation. And I want to start the presentation by sort of having three running questions. So what are important things to improve, say, scale, evolve our tech organization, and why? And how can we do that effectively? I think Tom already touched quite a lot of this, so but I'm going to take a slightly different angle on this. And I will start looking at, say, modern ways of how we build our products and our organizations, namely product thinking and also DevOps. And I will spend some time on that, and then I will go into the socio-technical part. And let's talk then a bit about product thinking. And this is a nice visualization about the core idea and elements of product thinking. So product thinking can be seen as the journey from the problem space of the users to the solution space of the business. And our goal, and the goal of product thinking, is to reduce that gap, to manage that gap between the users and the problems, challenges they have, and they want to get solved, and the business. So because business has goals, increasing the revenues by a certain amount, blah, 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 that sort of thing. They are not always aligned. So the problem thinking aims at product thinking aims at finding how can we balance these. And technology is depicted here as sort of the means to embody and deliver the product to the customer, from the business to the customer. I think this is a great visualization because it sort of shows the main elements. However, I think it misses a few things, and namely, this is not a static thing. This is a rather dynamic thing. So we are, in order for us to build a good product, we need to continuously learn with the customer. So I prefer to think about product thinking in these terms. So it's about customer-centric discovery and delivery, while still taking into account the business goals. And this is a very important thing, because as Melissa Perry, a guru on product thinking and management, states, our highest priority is about it's to satisfy the customer through early and continuous delivery of valuable software. And I double highlighted here the valuable, because at the end, our goal with product thinking and actually any activities we should be doing on our business is about maximizing this value exchange with the customer. And this value can mean many different things. It can be money. Most of the time it's about money, but it can also be loyalty, or can be some other things. Nevertheless, if we don't have a clear goal about what are we doing to maximize this value exchange, we probably are not well synced into building the best product. So now, how can we do that? So how can we continuously and at high velocity maximize the value exchange with the customer? Because remember, this is a product. This is not a project. So this is something that we are continuously building and evolving as we discover new things from the customer or from the market, like Tom mentioned. So there are a lot of things happening, and this will evolve with all of these factors. Also, our organization changes, so we also need to cater for that. There are new priorities, there are new people in, it grows, etc. So there is a lot of factors that needs to be taken into consideration. So, but isn't DevOps or BizDevOps, or actually today all of the letters DevOps, already answering these questions? Well, I think it helps on answering partly of these questions. Certainly breaking the silos between, let's say, IT and business will definitely help us on improving things on certain parts of our organization. However, there are more factors that may influence these equations. And this is really the focus of my talk today. So how can we have a way to capture those factors so that we can design our organization and our products, taking all of that context in. And to talk about that, and I think some of you have seen this picture before, I will be talking about restaurants, because namely what traits make great restaurants. And because restaurants, like software products, are about maximizing the value exchange with the customer. So the customer comes in, has a great food, has a great experience on our restaurant, and they will happily pay for that. And maybe they even recommend us to their friends. I know that a restaurant is a sort of a weird example these days. I thought about this right before Corona, but we will be going back to restaurants soon. So let's stay positive. But for now, let's look at some traits that make great restaurants. The first trait is your staff defines the restaurant cooking and experiences. So if you want to have a restaurant that delivers great French food experience, you better make sure that you bring good French chefs, wine experts, and people that understand that. And you also want them to actually work together to build those experiences. So this means basically your teams shape your product. And so this is basically Conway's law. So whatever product you are trying to build, you need to make sure your team is aligned with those goals. The second trait I want to touch on is about the fact that chefs cannot cook, serve the dishes, the wine, all of that at the same time. So basically this has to do with the fact that your teams must have the right conditions and capacity to build the product for your customer. So Tom already touched a few of these things. So we need to be explicitly on considering the teams, their topologies, their setup, to make this work. It's not just about the technical architecture, as we tend to do a lot. So basically, this is also, again, referring about team topologies from Manuel and Matthew, and how to build teams that can be set up for fast flow. So they are not overloaded all the time, and they have the right conditions to succeed. The third trait I want to touch, which is a very interesting one, has to do with the fact that a restaurant is a combination of parts. And so you have people cooking, people serving the wine, people serving the dishes, cleaning, getting the produce into the restaurant. There are a lot of things happening. So the restaurant has these different parts and people working in parallel. However, we want to make sure we provide a great combined product at the end to our customer. We don't want to just have a random set of local optimizations coming together. So think what would happen if you would say, hey, cook me the best fish dish, and you bring it to the customer, and then you say, hey, bring me the best wine of the world and bring it to the customer. The customer will have like these two best things on their own, but the combination most likely is not the best. So to optimize and build great products and great things, we need to look at all the parts involved and their interactions. Those interactions are the ones that define the product. So in a nutshell, your product is the combination of the different value streams in the organization aligned to maximize the value exchange for the customer. The fourth trait, and this is the last one, so it has to do with the fact that for us to have successful restaurants, we need to enable our teams to discover new recipes and learn what works for our customer and restaurant. And this has to be a continuous thing, because you cannot just stop if something works well today, because things change. It's just a fact. So the produce around our restaurant will change, the customers will change, the market changes. All of these things change, so change is unavoidable. So we need to embrace it and make sure that we enable our teams to evolve and discover how to evolve our restaurant to cope with that. So we need to strive to have teams empowered to do that. Everyone, not just a selected few, but everyone should be able to do that. So if we recap these 4 traits that I shared here, we start seeing that in order for us to actually address this goal that we have to maximize value exchange with the customer continuously at a high velocity, we can't just focus on local optimizations. So this is about considering the restaurant elements, parts, and their interactions, how they contribute to create the best restaurant. This is why DevOps, or product thinking taken separately in parts of our organizations, they will certainly do good there, but are they doing the good that we want for the whole organization? Are they a complete solution? And the answer is no. But I have here, I forgot I had here, these are some books that are also interesting on these different traits, and I will share also them at the end and also share the slide deck afterwards. So what I'm coming into is that we need to zoom out and start designing and approaching our system design from a more holistic perspective, where we can address the different parts, the context, in the context of the whole. So how do they fit here? So if we look at at this diagram, we start seeing that in order for us to achieve the goal of product thinking, we can't just focus on the what here. what enables the maximum value exchange. We also need to create the conditions for the interrelated systems to work well. So the who system, who is doing this? The teams. And also the how system. So how are we actually doing this? What's the technical architecture we have behind our system, for example? So we have to make sure that all of these are considered when we are trying to improve the overall system. Otherwise, we just have local optimizations. And this is basically where systems thinking can help a lot, about taking this more holistic view and design from the whole perspective. And I will not be able to share the ins and outs about systems thinking in this little time, but, so I'm still myself learning a lot about this. So I will share some quotes from Russell Ackoff here, which was a reference in this topic, and he's definitely someone worth to look into on this topic. So the first element I want to share is that understanding proceeds from the whole to its parts, not from the parts to the whole, as knowledge does. So this is a great statement. And understanding is about answering the why questions, and you can only truly answer those if you look at the whole. So in our case, we look at the restaurant. We don't just look at how to cook a dish. The second element, which is necessary to do that exercise, is how do we need to identify the whole that makes that is relevant for our situation. And for example, in the case of a car, if we want to understand the car, you need to identify and position it in the transportation system. So the car has a purpose within the transportation system together with other means of transportation. And the third point is also a very interesting one, has to do with, in order to manage a system effectively, we should focus on the interactions of the parts, not on the behaviors that the parts have separately. And so coming back to our restaurant example, in order for us to make a great dish on the kitchen, we need to look and understand the whole restaurant. How does this dish contribute to the whole restaurant? So, for example, we need to see, like I mentioned earlier, what is the best wine that goes with this dish? How do we go and serve the customer? How do we get produce to produce this dish? So we think about the relations and with that, we look at how to bring the best outcome for our system. In this case, the system, the whole around these parts is the restaurant. So to reiterate, we are about improving the system as a whole. We are not interested on purely improving the parts in separation if they don't improve the overall system. This is many times waste that we create, because why are you cooking the best dish if at the end the experience to the customer was not didn't increase the satisfaction of the customer because the wine was poorly chosen, for example. So I think if Ackoff would be here today, he would say something like this. So you should never improve the quality of the dish if that doesn't improve the overall quality of the restaurant simultaneously. It sounds weird when I say this, but just take a moment to reflect on that. We really don't want to optimize locally without context, just for the sake of improving. Why would we do that if the overall system or product does not improve? This is why local optimizations are so dangerous. It's working better for us, some team may say, right? So, but then at the end of the year, if you look at our product as a whole, maybe it's not doing better. Maybe it's doing worse. For example, in my case, I work for an online shopping website, right? So if we have our recommendations team producing the best recommendations, but doesn't look at how search team or teams are working, and they don't provide together more relevant content to our customers, that's not a good step that we are taking, because customers are not getting the most relevant offers on our website. So this is why we need to look at holistically how to improve the system and not just the parts. And this may all sound cool and logical, but what about the next step? So how do we start thinking about systems and how to understand them? And for that, I will now go into a few reference tweets. And I will start with this one from Ruth Malan. And it's about, it's a right-hand rule, like the old times physics right-hand rule. And the idea is very simple. In order for us to understand systems, we must understand the context. So we really need to understand the context. And then we look at the structure, so the parts that we have within our systems, within the boundaries of our systems, and the dynamics. And this is about relations between the parts. And based on that, we also start seeing and observing what are properties that rise from those interactions. And these are things that are, in general, emerge and generate new properties on our system. And those are very powerful things. All of this allows us and provides us insight and understanding of what's relevant on our system. And then from there, we can start looking at basically using those insights to improve our system. So let's now look at, so I talked a lot about restaurants. So let's now spend some time on looking at how can we start approaching this in our own world of building software systems. And this is my current mental model on how I look at say, tech-driven organizations and the role that we should consider when trying to improve our product in such organizations. And this is a socio-technical system. Tom already touched this earlier, and this is about considering the social part, so the teams, the systems of work, but also the technical parts, the product we built. But I also add here the customer into this, because this closes the loop. This generates a loop where customers rise expectations. So they have certain expectations on the product. We are observing and discovering what are those as teams. And then we build and evolve our product based on that. And our product will be providing this value to the customer. And systems thinking allows us, if we zoom out and see this, allows us to see these relations and how do we go about empowering these different systems, these different parts, to basically allow to go from something we observe on the customer to implementing something and delivering it at high velocity. And this is key to maximize the value exchange with the customer. I want to now spend some time on how to basically start doing this, but before I want to share sort of a definition of socio-technical architecture, which is basically how we can go about holistically co-design these technical and organizational systems. So this is a definition I came up with because it was, when I started looking into this, I didn't find a good definition for this. So I started trying to create my own, and I asked a few people that were active on this to help me on upvoting which one would be the most interesting, and this was the one that we sort of selected. And socio-technical architecture then is about taking this holistic co-design approach to technical and organizational systems, given that they have this inherent impact on each other. Nick Tune was one of the people that upvoted this. He has been thinking a bit longer about this than myself, and he also added this sort of this extension, which which basically states that when we are architecting software systems, we must consider the impact on the teams, in the organization, and vice versa. So this really boils down to this holistic co-design. So we need we can't just continue designing our technical systems without considering the organizational or the teams behind it. And also, like I said on the previous slide, we need to understand what the customer is and how can we basically build a product that matches the customer needs. So now I want to spend some time on laying some ideas on how to approach actually socio-technical architecture. So how can we go about this co-design of technical and organizational systems? And I'm going to again mention a tweet from, in this case, Trond, who's also in the present here today. And this pretty much can be used on approaching socio-technical architecture design. And basically, Trond shares here like a diagram which has two axes. One is the axis of the wall, and the other is the axis of the parts. And if you see, this basically has like three main parts. The first part that you see here on the bottom is about basically understanding based on the wall and using feedback loops and data we gather from the different parts and the things we have to create that understanding, the synthesis. So in our restaurant example, this is, okay, how is our restaurant doing? What's going on with the dishes? What's going on with the experience to the customer, etc. Based on that, we start building hypotheses for direction of action on the parts. So this is the part that start going from the wall to basically the parts. So for example, in the case of the restaurant, we could say, hey, we can improve our dishes. We are noticing this is not working well. People are complaining the dishes are very, not special. So we could improve it by, for example, having fresher produce to build up our dishes. And then basically we will be taking action based on this context and this understanding. We will be taking action on the parts of the restaurant. So for example, we could just approach local producers to be suppliers of our restaurant. And with that, we are taking action and we are on the parts working on these elements. So if we look at this, we are interleaving between the wall and the parts. We are zooming in and out of the system. And in time, as we progress in time, we start basically learning interesting things. So new categories of things will emerge from these interactions that we observe in the system. For example, just the example I gave, imagine that we, as a restaurant, we realize, hey, fresh produce is really important for us. So we decide to build our own farm to cultivate produce for our restaurant, because that enables us to have this fresh produce. But maybe we can also use this as a marketing stunt for our restaurant, because it makes it like a nicer restaurant. These people are producing their own food. And this is basically called emergence in systems thinking. And this is a powerful element of systems thinking. And it just comes from the fact that you start looking at the whole and all of these interactions. You don't work in local optimizations. And by the way, I tried to create here a nice algorithm to represent this. So basically, you really go use this data, you synthesize what are the hypotheses that you will apply into improving your system based on all these feedback loops, the things you observe from the whole. And then you use that hypothesis to just to act and you will be continuously analyzing that, and more data will come, and this is an infinite loop. Cool. So let's now spend some time on, I think this is, to me at least, it's still a bit abstract, so I will try to use and share some examples of that I have been observing on my at bol.com at my work, and namely, I will share two examples today. So I will share how bol.com product organization architecture evolved in time, and how data science also evolved. So these are two examples of sort of patterns that of scaling and evolution. And I will take a socio-technical architecture lens to analyze it. So let's go into them. And before I go into actually the patterns, I want to just share a bit of a timeline. It's a very, very yellow slide. But yeah, bear with me. So basically, this is the timeline of the company. So you can see that we started end of the 90s, like another popular online retailer. And like them, we also started selling books. And in time, what you see is that we started to just have all of different categories, including since 2018, we also sell alcohol in our own web shop. I highlighted two key moments here, and they will be important to share the examples. The first one is we started allowing businesses to sell on our website. So we shifted from being just an online shop to be a platform. And the one underneath focuses on shares that we were also taken over by a huge, a big holding in the Netherlands on the basically the leader on food retailing, and that meant that we basically got a huge support to grow even more. So these two events meant that we needed to grow a lot from those moments. And you can see underneath that basically we now have like about 12 million customers, active customers in Belgium and Netherlands, and 42 professional sellers sell through this, through our platform. And why is this important? This is important because if you look, our product organization and architecture, they grew hand in hand. And this is why it's really interesting to look at this from a socio-technical perspective. So if you look at the lane in the bottom, it's about the product, then you have the technical architecture, and on top you have the organization and also ways of working. So when these big events happened in the company, like starting to become a platform, so we want more sellers to sell there, and also the investment we got from this, from Ahold, when we got acquired, all of that meant that we had to grow immensely. However, our organization and our technical architecture were not appropriate to grow quickly at high velocity. So this meant that we had to really go and make sure that our organization was basically reinvented in a sense. So we started adding, becoming more agile, but also adding creating real DevOps teams. And this was also exactly around the same time. And we had a monolithic architecture, which there is nothing bad with that. But for our case, we were so many teams and we had so much going on that it didn't work. So we knew that we wanted to go into a microservices. At the time, still we were calling this more like service-oriented architecture. However, if you look at this, these went hand in hand. So we first made sure that our organization was set up clearly. So we have DevOps teams with empowered to own their own applications to work on them effectively. And only then, only after creating that and platform support for them, we were able to implement microservices. And then if you fast forward to the second highlighted part here, you see that we actually, so this 10 here on the bottom, 600, this is the number of services, applications we have. So on the second highlight we have, there was another pivotal moment because we again had like we had to reinvent a bit ourselves to increase, to grow even more. And our teams were really struggling to basically do that work effectively. And this meant that, and also we still had this big separation between business and more the IT side of the company, and we wanted to address that because we are basically growing immensely. And what that meant was that we had to again look at our socio-technical system and see how could we address this. And this is when we went from just this DevOps teams working on microservices to DevOps to product teams working on clear value streams to the customer, because they sort of got lost during these years. The teams were just owning parts of the landscape, but not necessarily working on clear value streams to the customer. So we went and we have now, and this is rather new, so this is since basically 2019, 2020. We have now around 100 product teams, and they are organized around products. So we went from having like these 600 applications, sort of a jungle of microservices, to have like around 50 products or 50 parts of the landscape with clear value streams identified. So in both of these cases, what you see is that the sort of the product strategy is driving big changes on our landscape. We need to take decisions on how we organize our teams and our architecture based on that. And for example, if you really need to take this holistic view into approaching this. The good example of this is you should never just adopt microservice because it's a fancy thing. It's hell if you don't have DevOps teams and the proper platform to support them. So you really need to holistically look into this. And the last remark I want to make on this slide is that and it's another thing that you also see is that the changes continue. So we are changing all the time. So we should not get attached to a specific phase of our socio-technical architecture or life of our product, because there are so many factors that will influence this that you really need to just embrace the change and look at ways on how can you improve your system. So it's really important to have these feedback loops and to create the understanding of your system. My second example, and I will use like a slightly different visualization, focuses on another interesting example, one that I worked very closely with over the last 3-4 years. And it focuses on how data science evolved in the company. So you will see on the sort of the way I'm going to represent this is on the bottom, you have like the 3 dimensions of the socio-technical architecture parts, their state. And then we basically go and apply the algorithm that I shared before. So we will be creating an hypothesis. So we will be observing there is a challenge, there is something. We will be observing that from the whole perspective. And we will be synthesizing and thinking, creating this understanding and hypothesis about how can we act on the parts. So this is just a way to start seeing how could we do this in a more systematically way. So now let's then look at data science. how it came about at bol.com. And again, the 2012 comes into place. So driven by this huge growth, the need to scale our ability to handle complexity, but also be more relevant to our customers. Because remember, we are offering, each product has multiple offers. So for example, think like a MacBook. We can have multiple sellers offering a MacBook, but which one would be more interesting for a particular customer? So you start having this sort of challenges. And those are the sort of challenges that data science and machine learning can help you a lot handling. Furthermore, we were growing so much that we needed to, for example, have better ways to forecast our sales and that sort of thing. So data science really can be helpful on that. So what did we do? And let's first look at the context. So we are moving to becoming a retailer platform. In terms of product organization, we have around 20 DevOps teams, mostly engineering and product, no data science present yet. And we have a technical, a service-oriented architecture. So the problem was indeed we need to have data science to improve the relevance of our product and address this complexity I just shared about. But we also had another problem, which was we don't have any data science people in the organization yet. So after considering this and the whole context, what we started doing was to get in some data science pioneers. And we started doing data science projects on strategic parts and products or parts of the company. Furthermore, we also started building the technical, the tech that we need to do data science. So this meant that in terms of products, we started having data science projects on strategic parts of the products, like recommendations and sales forecast. On the organization, we started having the data science pioneers on some teams. And tech-wise, we started having developing some platform to do data science. For example, creating a Hadoop cluster to run data science jobs. However, just some context, extra context here, data science has some particularities on ways of working. So it's not a one-to-one to a normal engineering, software engineering work. There is a lot of overlap, but some things are not done the same way. And another one that basically will trigger the next phase is that we were doing projects. And so data science pioneers were just jumping around from team to team and just implementing a project in one product and then going to the next gig. Fast forwarding about 5 years, so we are around 2017. So we now, in terms of product, we have we really embraced, we want to be a retailer platform. So we still have our own shop and our own stock, but we really want to empower sellers selling on our platform. We have about 70 DevOps teams. So we went from like 20 to 70, huge growth. And we have now like 10 data scientists. And we are now like a consolidated microservices architecture, and we do have some infrastructure to do data science. So our problem at this moment was that actually we cannot, having data science projects doesn't fit our philosophy for our DevOps teams, which was and is, you build it, you run it, you love it. So this is our motto. And another problem we had is that we had these pioneers going around, but the maturity of data science in the organization was still very low. So what did we do? Then we took a step, and I was present in this. We took a step of creating data science teams. So we have teams that are focused on doing products that are strong on data science. So we created these teams and a department to support them on, say, highly potential areas. And we also had the focus of maturing the data science discipline. So what we ended up doing then was, in terms of product, we have now data science being owned by the teams that do it. So this is a concern we addressed. There is ownership. We have like 10 data science teams created on high potential areas of the company. And technically we continue having Hadoop, but we also, this was a moment that we were also starting to go to Google Cloud. So there were a lot of opportunities in terms of technical architecture and ability. But as you may imagine, and if you look at the number of teams we have, so say fast forward to last year, beginning of 2020, we are now about 110 teams, and we are growing a lot and becoming a product-led organization. So we have this real clear products with a clear value stream to the customer. And yeah, and we have more data scientists. So now we have about 50 people working as data scientists or machine learning engineers. We have this data science leadership team, or data science leads are also maturing. And our architecture is also maturing, technical architecture. But the idea of having data science teams organized in a central department was not aligned with the rest of our architecture. So basically, this was counter-intuitive, and also was creating, say, data science islands in the organization. So what we did was, and this was something I actually was advocating since the beginning of the previous phase, but the previous phase was good to develop the ability of doing data science and bringing people in, was to stop this department. So we stopped the data science department, and we just established data science as a discipline that products can pull and use like we do with engineering disciplines. We still have some teams that are very heavy on data science, and they are sort of what Manuel would call complicated subsystems or even platform teams using team topologies language. However, we have now 50 products and many, so 110 teams, and a lot of them, these more stream-aligned teams, they also need data science. And with this, we created a way to basically allow data science to be in the products that need it. And yeah, so this sort of wraps up my story about the data science, and this is not yet over. There will be more things going on, but with this, I wanted to show you how we go about changing this. So we are continuously changing our system. In this case, I show it as a socio-technical system. We are continuously changing based on these observations and how we are looking at how to maximize or balance the properties of the whole system. And this is a continuous thing. So this allows us to start addressing the questions we had at the beginning. If we start going into this, zooming in and out, we start looking at what are the important things to improve and why at each moment. And by having this holistic perspective, we can zoom in and act effectively on the different parts that need to be acted upon. So this is really the what and why is about understanding what's going on. And then we will zoom in and act on the parts with that understanding from the whole. And this closes my talk. So I've been actually writing quite a lot about this, so you can find it on my website, on this page. Also, the DDD crew has been creating a lot of interesting resources that also touch a lot of these elements. And here again, you have the books I mentioned earlier, a book of Manuel, but also a few others that address different parts of this process of socio-technical architecture and socio-technical thinking. And I think I do have now some time for questions. So
something that I never saw, and it was great to see because I also try to push for this is this data-driven orientation, and in fact pulling people to work on these and work with the teams and then start enabling teams. My question here would be, how did you persuade your management to have this capability inside of the teams? What was the business case that you used, or the logic? It would be interesting to know, or if it was something else also.
But do you have one of the specific cases that I talked about, Urbano?
Yeah, or, regarding having data scientists working. Okay.
Yeah. So it was like I shared, it was like a big journey. So we started with just a few people working on it, pioneering, and we started seeing that was not scaling. So we built up these teams, and management was really committed to invest on that. So management was backing and basically investing on doing that. So there was some selling from say middle management to, hey, we need to extra invest on data science. But it was also the pioneers opened the floor, the doors for that investment. So there was really they were showcasing how much a few people with the ability of doing data science correctly working on strategic products were generating huge revenues. So that was how the selling and the the investing on data science was driven. And today it's still the same. It's a lot about showcasing how much some experiments on recommendations say increases our how much we are able to sell, how we maximize the value to the customer. So like the thing I was talking since the beginning. So it was really about showcasing the outcomes of the work of these people.
Thank you.
Great talk. As I think someone else said in the chat, was really good, the data science story, and I'm gonna probably chase you to write that into an article or something. I think it would be good to. These talks will be available. They are being recorded. They'll be available, but an article will be good. But I just wanted to rewind a little bit. I think one of the main things that one of the key things that you said that I don't see a lot of teams talking about is the fact that the customer is going to raise their expectation, right? When you're in that cycle of maximizing value, you are providing, the initial value, and then client is going to ask for more if you're successful. And when you have teams that are very technical, they're not empowered to think about the business, then you start. My question is, have you seen this at Bol.com at some point, where you're trying to empower teams to maximize that value, but they start to need to have a lot more kind of business understanding, so they can think about, is it feasible? Is it worthwhile to invest in building this solution for this problem? Because the clients, this is something that we don't talk about, but customers are not going to stop asking for more things, right? Or if they do, that's a bad sign for the organization. And we're often talking about products as if it's a sort of static thing where here's a set of features and then we're done and let's focus on the next thing. So have you seen problems? The question is, have you seen teams struggling, even when you had the DevOps teams, the build and run, that they were lacking some business?
Definitely, Manuel. I think 3 years ago, I talked exactly about that on our internal conference. So it was before it was basically my first example on the second highlight I had. That was the moment we really realized we are really good DevOps teams. We even call them IT teams, or there is all sorts of names we see them. But we still had these two silos. It was the business sitting on another building, and we had our IT teams. Are the names vary a lot, but that the point that you made, Manuel, it was exactly the critical point that we noticed. We were like 100 teams, IT teams, and we had a product owner just coming into the stand-ups and then leaving. And we noticed, hey, this is not working anymore. We really need to recalibrate and have these clear products, and everyone that is needed to make this product work and listen to the customer, experiment with the customer, needs to be on these teams. And this is where we are now. So we really invested on becoming a product-led organization, and we build a lot of these things. So data science is sort of related with that, because it also brought in things like one of the sort of the platform teams we have now. It's a mix of platform and enabling. It's experimentation team. So we strategically invested on experimentation team to enable these teams to actually run even more experiments with the customer. And all of that was a strategic decision by the company to just enable the teams to stop being these islands and have a clear focus and mission on their customer. Yeah. So maybe just an interesting one, for example, what we also did on those teams, because each product is like a group of several teams, because as you may well know, Manuel, you cannot have teams, effective teams much bigger than, say, eight people or so. So what we have is that each product that cannot just fit in one team because of the cognitive load aspect. So we have our product teams are formed of multiple, a product team has like multiple DevOps teams with the product people inside. And then what we have is per product, we have like a co-leadership that mixes the product, the engineering management, but also like the a technical lead, and those are helping on this team on aligning on these different forces that a product has to deal with, including like Tom mentioned, the technical debt aspect. How can we make sure all of the parts are taken into consideration? Yeah.
Thanks.